You've recently transitioned your operation to drip irrigation. It's a significant upgrade, but it presents a new immediate question. How do you determine the exact volume of water your system needs to deliver today? Guessing your water application leads to physiological stress. When a plant doesn't receive the specific volume it consumed yesterday, it begins to wilt and suffer permanent damage under the sun. By the end of this video, you will have a specific data-backed number to program into your irrigation controller. To calculate that number, you need two pieces of information: the current growth stage of your crop and yesterday's local weather data. Gathering these two prerequisites shifts your irrigation strategy from a series of guesses into a repeatable, scientific process. We begin by viewing the soil in your field as a water reservoir with a specific capacity to hold moisture. Water leaves the reservoir in two ways. It evaporates from the soil and transpires through the plant's leaves. This combined loss is evapotranspiration, or ET. Your irrigation system's goal is to perfectly replace that lost volume, keeping the reservoir balanced. Maintaining this one-to-one balance ensures the plant has constant access to water without the risk of oversaturation or waste. We start with a baseline value called ETO. This represents the amount of water lost from a standard surface of grass based on yesterday's temperature, humidity, wind, and radiation. You can find yesterday's ETO value on a local weather station report or through a dedicated meteorological app. However, grass doesn't consume water at the same rate as a high-value crop. Weather data alone isn't enough to determine your field's specific needs. This is why we use a crop factor, or KC. This multiplier is found by consulting crop literature or an agronomist, and it changes depending on the specific growth stage of your plant. You cannot use the same KC value for the entire season. As a plant moves from vegetative growth into flowering, its water demand changes, and you must update your multiplier accordingly. Combining that baseline weather data with your specific crop factor allows you to track the shifting water demands of your field day by day. To calculate ETC, multiply ETO by the crop factor, KC. Using an ETO of 6.5 millimeters and a cotton KC of 0.2, we get 1.3 millimeters. 1 millimeter over a hectare, 10,000 square meters, is 10 cubic meters. We must apply 13 cubic meters per hectare. This calculation works perfectly for daily irrigation, but your schedule might involve skipping days between watering. If you irrigate every 3 days, you must add together the ETC values for every single day since your last irrigation event to find the total volume required. By summing these daily values, you ensure the system replaces exactly what the environment removed, keeping your soil reservoir full. You now have a precise measurement of the water your crop actually used. Applying the correct volume ensures that every plant in the row receives exactly what it needs to maintain steady growth without water stress. Now, take that calculated volume and program it into your irrigation controller or pump timer. To maintain this balance, continue tracking the daily ETO readings and update your crop factor as your plants mature. Performing this calculation daily ensures your irrigation system maintains a perfectly stable soil environment for your crops all season long.